This is a video from section 10, chapter 10, excuse me, section 2 on regression. We'll be looking at regression analysis, finding p-values, comparing the p-values with your test significance to be able to determine whether to accept or reject the null hypothesis, and then from there to establish an equation of linear regression and look at its scatter plot and such. So remember, we always start off with the hypothesis. The null is equal and the alternative is not equal. So at this point we need to choose a graph. So we could very easily just come up here and take our ordered pairs like 526 and 530 and come down and find 526 and 530 and you know, and kind of move around that way. But what I want to do is I want to take a moment and show you one more time with the graphing calculator how that's done. So here we go. We are going to go into the graph calculator. We hit stat, and I want to show you how to clear the list. So remember number 4. We need to clear our L1 and L2 because that's where we're going to put our data. So you'll notice L1 is above the number 1 key, so second L1. You put a comma in between, comma's located in the middle there, and then second L2, which is on the number 2 key. You press enter, and it's done. So now when you go into stat, go into number 1 to go into your list, you'll notice your lists are actually empty. So go ahead and start putting your numbers in. 526 equals 504, enter, excuse me, 594. I'm going to hit pause while you keep doing that. Alright, got my data in. Hopefully you have yours in. Double check that your data lines up. You've got 5 in each column, and we're ready to move on. So before we go and do our scatter plot, we want to make sure that our window is clear. So go ahead and push your y equals button for me, please. These are your graphing keys, and so I want to look at y equals. And you'll notice there's already something in there, and I want to get rid of that. So I want to make sure all of those y equal lines are clear, so I press clear to clear that one out. Alright, so now I'm going to go ahead and go into, right above the y equals, it says stat plot, and that's written in blue. So I hit second, stat plot. I choose plot number 1. Okay, and I'm going to set my window up and then you try to match yours. Remember to go, you can go side to side. So if you want to turn something off, if you want to turn it back on, you go on top of it and press enter. Go down and set up if you want to move down, and then you can move across if you needed to. But we want it on Scatterplot. By default, it goes L1 and L2. Okay, now before I graph, I want to make sure that my window that I'm going to see right here is going to look like this window, which they have right there. So we're going to set up our window. So my x min is 400, my x max is 700, my scale is 20, 4, 24, 44, 64, 80, and so forth. My y min is 400, my y max is 700, and my scale is 20 again. So I set that up in my window, and once I have that set up, I go ahead and hit graph. Which I come to find out, it looks like that my graph is going to be A. So I go ahead and choose graph A, which I already had to do because I had to double check that I was going to get the right video, or excuse, the right type of question. Alright, so we're good to go. We got graph A, and now we're on part 3 of this particular problem. They want us to find our correlation coefficient so we can do a test of significance. So if you remember correctly, we're going to go into stat. We go over to test. Oops, I'm sorry, I don't want a z-test. Excuse me, I hit the wrong button. Stat. Over to test. And we go down to letter F on the 84. And I think letter E on the 83. Went too far. There we go. Linear regression t-test. Okay, choose enter. Okay, by default it sets up L1, L2. Double check your window looks that way, please, and go down to calculate. Alright, so here this gives us everything we're going to need. So we kind of scroll down, we're looking for R, our correlation coefficient. They said round my answer to 3 decimal places, so that's going to be 0.989. Check. Alright, super duper. Now they want our p-value. So we come back up here, and there's my p-value. So we got 0.001. So therefore, what we have to remember is that are we going to reject or are we going to not reject? Okay, so that's kind of the question. It's not necessarily a question of accepting. It's a question of rejecting or not rejecting. So let's go back to my presentation here and see if we can remember. Alright, here we go. So to remind ourselves, in this case here, what happens is that if our p-value is less than our significant value, then we will reject the null hypothesis. If my p-value is greater, then we do not reject. So let's take a look one more time. Ooh, wrong button. Sorry about that. Let me get back on track here. There we go. So my p-value is 0.001. My test value is that. So therefore, I am less than the significant value. And one more time so you see it. If I am less than or equal to, I will reject the null hypothesis. So I reject it, which this allows me to move on. This allows me to go to the next step. Alright, so now they want me to go ahead and find the equation. So since I'm going to go ahead and move on and reject my null, then I'm going to go ahead and move on and test this stuff. So my equation is located actually right here. It's right here in front of me. There we go. Okay, so in my linear regression equation, I have an A coefficient and a B coefficient. So I'm going to take that A and B coefficient, which are located right here, and put them into my equation. So now I have 58.233. My B value is positive, so plus 0.910x. So all I've done there is I have basically taken these data values, found an equation where these A and B are my coefficients in this format for my linear regression, and I'm ready to go. So I test that, I press okie dokie. Alright, so now they want me to find the equation. Well, this is pretty straightforward when it's multiple choice, because you can clearly see that, on the first question you chose A for the scatter plot. So now if you come down here, well, A is still my scatter plot. So the correct answer is A, but I also want to take a minute to look at the actual, how do we do this with a calculator? Well, if you remember a minute ago when you did your regression line, you actually when you did this calculation, it actually went, I'm going to go back in real quickly. Right? It actually asked us where they wanted us to put our regression equation, and we told it y1. So when we did this calculation, you'll notice, sorry about that, when we did this calculation, our actual equation went into y1. So if I hit graph right now, that equation that we just typed in, this guy right here, that you just typed, oops, I went too far. This guy right here actually went into the equation, into the graph. So he's right there on top of my scatter plot. So here's the big question. Here's the big picture. If we compare our A to B, C, and D, the reason we talk about correlation is when you have a correlation close to 1 or to -1, that's a very positive situation. That's a strong correlation. The further you get away from 1 or -1, the closer you get to 0, the weaker the correlation of the data. So in statistics, what we do, in the study of statistics, we collect data. We can't collect data from everybody. We collect data from a few sources. We use that data to make predictions about the entire population. So we take a sample, we use that sample to create equations or patterns, and we use those equations to make predictions about others. So you can see here, if you look at B, there's no correlation here. There's no common thread. Same thing with C, same thing with D. But when you look at A, look at the strength of that correlation. Look at the relationship to that line that goes through, how close it is, the fit to that line. Alright, so as we go down here now, we get to summarize these results. So there is a significant evidence to conclude a linear relationship exists between the SAT and the SAT verbal and the SAT math scores. Which means is that if I come up here one more time and look at this, if a student scored a 680 on the verbal, then I can predict that they're going to score about a 680 on their math portion. I can also use my equation, my regression equation that I created, to test that. So if I use the regression equation, I say, okay, if a student makes a 560 on the verbal, what will they make on the math section? And I can do that. And that's the idea of a regression equation.